Volume of prisms and cylinders. Our objective is to learn and apply the formulas for the volumes of prisms and cylinders. Who uses this? Marine biologists must ensure that aquariums are large enough to accommodate the number of fish inside them. Well, what is volume? Volume is the number of non-overlapping unit cubes of a given size that will exactly fill the interior of a three-dimensional figure. Cavallari's principle says that if two three-dimensional figures have the same height and have the same cross-sectional area at every level, they have the same volume. So, with that in mind, the volume of a prism with base area B and height h is the volume equals the area of the base, whatever that happens to be, times the height. Area of the base times the height. If you want, you can go more specifically, because the volume of a rectangular prism with length L with W and height h is, the volume is length times width times height, or area of the base, which is length times width times your height. And for a cube, well, length times width, which is S and S, times your height, which is S. So, S cubed. Alright, well, let's try a couple. Find the volume of each prism. Round to the nearest tenth if necessary. So for A, we have a 10 by 12 by 8. So we are simply going to multiply 10 times 12 times 8. And when we do so, we get 960 centimeters cubed. Now you're dealing with volume, so you cube things. Alright, well, take a moment and try this next one on your own. Okay, now that you've had a moment to try this one, let's look at it together. A cube with edge length 10 centimeters. Well, it's a cube, so you know your length, your width, and your height are all the same. So therefore, your volume is just going to be 10 cubed, which in this case is 1,000. And we have centimeters and volume, so it's cubed. Alright, the aquarium at the right is a rectangular prism. Estimate the volume of the water in the aquarium in gallons. Now, the density of water is about 8.33 pounds per gallon. Estimate the weight of the water in pounds. Hint, 1 gallon equals 0.134 feet cubed. And your step 1 would be to find the volume of the aquarium in cubic feet. Take a moment and try this one on your own, and then we'll try it together. Alright, now that you've had a moment to try this one on your own, let's try it together. So find the volume of the aquarium in cubic feet. Well, it's a rectangular prism, so we can have 60 times 120 times 8. Hold on. 120, the 2 never showed up. 120. There we go. 60 times 120 times 8. And that will give us 57,600 feet cubed. Alright. Well, that's step 1. Step 2 would be to find or estimate how many gallons that we have here. Well, if 1 gallon is about 0.143 feet cubed, we can simply take our 57,600 and divide it by 0.134. So we have 57,600, and we're going to divide it by 0.134. And that's going to give us about 429,851. Alright, so now we know that each gallon weighs about 8.33 pounds. So now we can take our 429,851 and multiply that by 8.33. So we have 429,851 times 8.33. Now, that is going to give us about 3,580,659 pounds. Now, that is a lot of water. Let's try looking at cylinders. Cavalari's principle also relates to cylinders. The two stacks of CDs have the same number of CDs, so they have to have the same volume, even though one is a nice clean stack and the other one's kind of been shifted over. Alright, well, what are the formulas? Well, the volume of a cylinder with base area B and radius R and height h is the volume of the base area times the height. And our base area, since it's a cylinder, is pi r squared. Let's try these next ones. Find the volume of each cylinder. Give your answers both in terms of pi and rounded to the nearest tenth. Take a moment and try this first one on your own. Now that you've had a moment to try this one, let's try it together. Well, we have the area of our base times our height. So in this case, we have pi times our radius, which is 8 squared. And then we are going to multiply that by our height. So we have pi times 8 squared times 12, which gives us 768 pi, which is about 2,412.7 centimeters cubed. Notice we're still using cubed because we're talking about volume. Alright, well, let's try this next one. A cylinder with a base area of 36 pi inches squared and a height equal to twice whatever the radius is. Well, we need to first figure out what the radius is. So, we know that pi r squared equals our base area, which is 36 pi. Since pi is on both sides, we can divide pi on both sides and get rid of it. Now we just need the square root of 36, so our radius is 6. Now our height is equal to twice the radius, so therefore our height is 12. And now we can figure out our volume. We have our volume equals the area of our base, which is 36 pi, times our height, which in this case we figured that out was 12. So 36 times 12 is 432, and keep our pi here, and that is going to be about 1,357.2 inches cubed. Alright, well, let's try dealing with composite figures. Find the volume of composite three-dimensional figures. Find the volume of the composite figure and round to the nearest tenth. So to do that, you're going to find the volume of one figure and find the volume of the second figure and then just add them together. Unlike in surface area, you don't have to worry about what parts are touching what and what you need to subtract. So take a moment and try this next one on your own. Now that you've had a moment to try this one on your own, let's try it together. The base area of the prism. So the base area of the prism, we're going to have our base area is equal to 1/2 our base times our height, and since we know we've got a right triangle here, it makes it a little bit easier for us. So we have 6 times 8. So 1/2 6 times 8 is 24. And we're in meters, so meters squared. Now we can find the volume of our prism here. So we have our volume is going to equal the area of our base times whatever our height is. And in this case, the height of our base here is 9. So we have 9. So 24 times 9 is 216 meters cubed. Alright, well, the cylinder's diameter equals the hypotenuse of the prism base. Alright, well, we need to figure that out. Now to do that, we can use Pythagorean theorem. So we have 6 squared plus 8 squared equals our c squared. So we have 6 squared plus 8 squared equals our c squared. So we have 36 plus 64, which is 100, and the square root of 100 is 10. So therefore, since our diameter is 10, our radius must be 5. Once we have our radius, we can now use the formulas for our volume of a cylinder. So, volume of a cylinder equals pi times our radius, which is 5, squared times our height, and in this case our height is 5. So we have 5 squared, which is 25, times 5, which gives us 125 pi. So now our total volume is going to be 216 plus 125 pi, which is about 608.7 meters cubed. And that concludes our lesson on volume of prisms and cylinders.